Hi my dear students. In this video, we are discussing geometric series. Generally, to test the convergence of the series, necessary condition if limit n tends to infinity un is equal to 0. Then the series may be convergent or divergent. For that purpose, we will use the first method is geometric series method. So one more method, that is T-series method. These two test this geometric series and P-series test. By the observation only we can say that convergent and divergent. Okay, so we see the first geometric series. So what is geometric series? A expression like that, summation n from 0 to infinity x raised to n is equal to summation n is equal to 1 to infinity x raised to n minus 1. This expression like that, 1 plus x square plus up to x raised to n minus 1 plus so on. Okay, so this is the infinite series. This series is called a geometric series. Okay, so when you say that the geometric series is convergent or divergent and oscillatory. Okay, so using one important theorem, show that the geometric series summation n is equal to 0 to infinity x raised to n is, first one, the convergent. If the given series is convergent, if modulus of x is less than 1, by the definition of modulus, the value of x lies between minus 1 to plus 1. The second method is divergent. When you say the given series is divergent, if x greater than or equal to 1. And one more method, that is third case, the oscillates if x value is less than or equal to minus 1. Okay, now see the proof of this geometric series is proof. Let Sn be the nth partial sum of summation n is equal to 0 to infinity x raised to n. So that is sum of the nth terms is equal to 1 plus x square plus up to x raised to n minus 1. Okay, so we know that the sum of the nth terms means we are adding nth terms up to nth terms. Here 1 plus x square up to x raised to n minus 1. So here x raised to n minus 1 terms. That means here nth terms. Suppose we take S3, sum of 3 terms, that is 1 plus x square. We have to consider only 3 terms S3. Okay, don't consider the power of x. Only we have to add the number of terms up to nth terms. Okay, so now the first case, if modulus of x less than 1, so we know that is minus 1 less than x less than 1. So now write the sum of the nth terms once again, now using the sum of the geometric series formula. So that is, we know that already, the series like that, a plus ar square up to so on. A is the first term and r is the common ratio. So using this formula, Sn is equal to a into 1 minus r raised to n divided by 1 minus r less than 1. You can use this formula if r is less than 1. Suppose r greater than 1, we can use this formula, that is Sn is equal to a into r raised to n minus 1 divided by r minus 1. Okay, so here I am using Sn is equal to 1 minus x raised to n divided by 1 minus x. Now we can split this equation like that. Sn is equal to 1 upon 1 minus x raised to n divided by 1 minus x. Now applying limit on both sides, we get limit n tending to infinity, Sn is equal to limit n tending to infinity in that term. Okay, now apply the limit. We get 1 upon 1 minus x into minus 0. That term is 0. Since limit n tending to infinity, x raised to n is equal to 0 if modulus of x is less than 1. This value is 0. So 1 minus 1 upon 1 minus x minus 0, we get 1 upon 1 minus x. Okay, this value is finite. So how it is 0? If x value is less than 1. I will give one example. Suppose I am taking x is equal to 1 by 2. So here I am taking r because the series is a plus ar like that. Okay. So now here x value. Suppose we take x is equal to 1 by 2. So 1 by 2 is less than 1. Okay. Now limit n tends to infinity, r raised to n is equal to 0. Then 1 by 2 to the power n is equal to, apply the limit value 1 by 2 raised to n. So apply the limit 1 by 2 raised to infinity. 1 by 2 raised to infinity is infinity. 1 by infinity is 0. Okay, so here that value is 0. Then we get a finite number. The sequence Sn is convergent. Okay, hence summation n is equal to 0 to infinity x raised to n is convergent if the condition is modulus of x less than 1. Okay, so when you say that the series is convergent, if modulus of x is less than 1, then we can say that the series is convergent. Okay, so now the second method, second case, that is if x greater than or equal to 1. If x greater than or equal to 1. So if I will take here two conditions. If x greater than or equal to 1, x greater than 1 and x is equal to 1. First I will take x greater than 1. So now write the sum of the nth terms Sn once again. Then using the formula r greater than 1, that is Sn is equal to a into r raised to n minus 1 divided by r minus 1. We can use this formula because r greater than 1 means here x greater than 1. Okay. Therefore, Sn is equal to x raised to n minus 1 divided by x minus 1. Now split this equation like that, x raised to n divided by x minus 1 minus 1 upon x minus 1. Now apply limit on both sides. We get limit n tending to infinity, Sn is equal to limit n tending to infinity, x raised to n divided by x minus 1 minus 1 upon x minus 1. Okay. So here the limit value, the x raised to n upon x minus 1, the limit value is infinity. If you take x greater than 1 value, if you take x is equal to 2, 3 and so on, if all are greater than 1. Okay, I will give one example. Suppose I am taking x is equal to 2, that means 2 raised to n. So apply the limit value 2 raised to infinity. 2 raised to infinity is infinity. So that value is infinity. Infinity minus anything. So again infinity. Okay. So limit n tending to infinity, Sn is equal to infinity. Okay. So this is infinite. The sequence Sn is infinity. Then the sequence Sn is said to be divergent. Okay. Then the series summation n is equal to 0 to infinity x raised to n is divergent if x greater than 1. Now we show that x is equal to 1. Okay. So another sub case when x is equal to 1. So now write down the sum of the nth partial sum 1 plus x square plus up to x raised to n minus 1. So here put x is equal to 1 through this equation where it is x. Then we get Sn is equal to 1 plus up to n times. Then addition of these all the terms we get n. Sn is equal to n. Now apply limit. Limit n tending to infinity, Sn is equal to limit n tending to infinity into n. Then apply the limiting value, we get infinity. Limit n tending to infinity, Sn is equal to infinity. Therefore, the sequence Sn is diverges to infinity, then the sequence Sn is divergent. Okay, so hence summation n is equal to 0 to infinity, x raised to n is divergent if x is equal to 1. Similarly, summation n is equal to 0 to infinity, x raised to n is divergent if x greater than 1. Both the cases, if x is equal to 1 and x greater than 1, in both the cases, the series is divergent. Okay, so one more case is there, that is last case. Case 3, if x less than or equal to minus 1. If x less than or equal to minus 1. Here also two conditions, x is equal to minus 1 and x less than minus 1. Okay, so first I will take x is equal to minus 1. So write down the sum of the nth terms. We know that 1 plus x square plus up to x raised to n minus 1. So don't consider the powers of x. Only we have to consider the number of terms. Okay, here nth number of terms is there. So now put x is equal to minus 1. 1 plus minus 1. So x in the place minus 1, plus into minus 1. Then minus 1 whole square, that is plus 1. Then minus 1 whole cube, that is minus 1. So we know that. So we get 1 minus 1 plus 1 minus 1 plus 1 minus 1, like that. Okay. So here, suppose I am taking two terms. First two terms, plus 1 minus 1. I am consider only two terms, we get 0. If n is even, two terms, I am taking two terms. If n is even, we take four terms, plus 1, minus 1, plus 1, minus 1. So again the value is 0. If n is 0, if n is even, we get 0. Okay, so if n is odd, we get 1. Suppose I am taking one term, we get 1. Suppose I am taking two terms, plus 1 minus 1 plus 1. Okay, so suppose consider two terms. Three terms, plus 1 minus 1 get cancelled, we get 1. Suppose we take n is equal to 5. Again we get 1. Okay, if you take n is even, we get 0. If n is odd, we get 1. Okay, so now the limit n tending to infinity, Sn converges to 1 or 0. Okay, this limit is finite but not unique. Okay, hence the sequence Sn oscillates finitely. Therefore, the series n is equal to 0 to infinity, x raised to n is oscillates finitely when x is equal to minus 1. One more subcase, if x less than minus 1. Let x is equal to minus r. I am taking x is equal to minus r in general form. We can take x is equal to minus 2, minus 3, minus 4, minus 5, like that. Okay, all are less than minus 1. I am taking in general form x is equal to minus r, where r value is greater than 1. So now consider the sum of the nth series. Then substitute where it is x, here minus r. We get 1 plus minus r plus minus r whole square plus up to so on minus r to the power n minus 1. Now using the formula for sum of the geometric series, that is Sn is equal to a into 1 minus r raised to n divided by 1 minus r, because r is less than 1. So the x value is less than 1. Okay, so now 1 minus, the common ratio is minus r, and first term is a value is 1. So 1 minus of r raised to n divided by 1 minus of minus r, then is equal to 1 minus, using the basic formula for minus 1 into r is again minus r. Minus r to the power n here. Okay. So split the terms minus 1 to the power n into r raised to n. We can write. Okay. Now minus into minus plus. So 1 plus r divided by 1 plus r. So now apply the limit in that equation. We get limit n tending to infinity. Sn is equal to limit n tending to infinity. Into bracket 1 minus minus 1 raised to n into r raised to n divided by 1 plus r. Okay. So now here n value is even, we get minus infinity. N value is odd, we get plus infinity. Okay. So if you take n is equal to 1, we get minus 1 into r raised to n. 1 minus r raised to minus into minus plus. If you take n is equal to 1, minus 1 raised to 1 is minus 1, minus into minus plus. So minus 1 plus r raised to n divided by 1 plus r. Now apply the limit value. 1 plus infinity divided by 1 plus r. So 1 plus infinity. Infinity plus any term is again infinity. Infinity divided by anything is infinity. Okay. We get plus infinity. If you take n is equal to 2, minus 1 raised to 2. So that is plus 1. 1 minus r raised to n. We get 1 minus r raised to n divided by 1 plus r. Okay. So 1 minus r raised to n. Then apply limit value. We get 1 minus infinity. 1 minus infinity is a minus infinity. Then we get minus infinity. If n is odd, we get plus infinity. If n is even, we get minus infinity according to n is even or odd. So now the sequence Sn is oscillates infinitely. Hence the series Xn oscillates infinitely when x less than minus 1, and therefore series x is equal to 1, n is equal to 0 to infinity. X raised to n oscillates infinitely when x less than or equal to minus 1. In both the conditions, x less than minus 1 and x is equal to minus 1. In both the conditions, the series oscillates infinitely. Okay, I hope all of you understood. Thank you.